Underwater recovery. A costly, dangerous, oftentimes impossible task. Yet as science directs more and more attention to the underwater world, as more and more activity of both a commercial and military nature occurs on and below the surface of the ocean, the need for revolutionary changes and advances in underwater recovery technique is apparent. Losses claimed by the depths are not just material. With research becoming commonplace at depths to 20,000 feet and more, the loss of oceanographic instruments and equipment can negate months of work, requiring considerable expense to replace data and equipment. National security may also be placed in jeopardy when equipment is lost in the open ocean with no means of recovery. With a total awareness of the problems caused by such losses, Rocket Research Corporation, already established as a leader in space technology, has expanded their horizons to the world beneath the sea, designing an underwater salvage and recovery system unique to the industry and setting a new world's record for deep water recovery. For 5 years, Rocket Research has been a leader in the design and production of rocket propulsion systems using hydrazine gas generators. Rocket Research now has adapted this concept of propulsion to create a completely new system of flotation. Termed Project Rise for reusable inflatable salvage equipment, Rocket Research successfully demonstrated this new underwater recovery apparatus in Puget Sound waters adjacent to Seattle. These tests were initially carried out in approximately 30 feet of water to permit underwater photography of the operation, and later at 720 feet. The boat, ballasted to give it a negative buoyancy of 500 pounds, was filled with water until once sunk, the diver installs a buoyant recovery apparatus called a buoy pack, consisting in this test of 2 fabric-reinforced rubber flotation bags with a capacity of approximately 8 cubic feet of gas each and a monopropellant hydrazine gas generator for inflation of the bags. At depths beyond practical diver operation, the equipment could have been installed remotely or carried as fixed equipment by the vessel. The system is based on established recovery techniques, that of flotation tanks, but using the monopropellant gas generator to provide gases on site at the ocean bottom. The system is thus completely independent of surface-borne hoses, lines, compressors, or grappling equipment. In these tests, the gas generator, equipped with quick disconnect gas hoses, was taken down separately by a diver and affixed to the flotation bags. The gas generator employed in these tests consists of 5 basic parts inside the black box enclosure. The hydrazine fuel storage tank is pressurized with nitrogen for transferring the fuel to the reactor on command. Control of fuel transfer is achieved with either an explosive valve or magnetically latched solenoid valve. In the case of the Project Rise test, this valve was actuated from the surface. The valve may also be activated on site by a diver or from a small underwater vehicle using a variety of mechanical or electrical techniques. The gas generator is a catalytic reactor which promotes the decomposition of the hydrazine fuel. Downstream of the reactor, is a short length of stainless steel tubing, which further cools the exhaust gases. At the end of this tubing is a check valve, which prevents seawater from backing up into the reactor. Upon activation of the valve, clean, cool exhaust gases, consisting of a mixture of nitrogen, hydrogen, and ammonia, are produced by the gas generator. Considerably larger volumes of gas can be obtained by using larger fuel tanks or by using multiple generator systems. Rocket Research has now completed the preliminary design of systems capable of operating at ocean depths in excess of 20,000 feet and providing buoyant recovery forces of up to 80 tons. There is therefore no limitation to the size of vessel or object which can be refloated with this buoyant recovery technique. The basic system can also be adapted for use as a safety device, being attached to either the inside or outside of a boat hull with appropriate containment. Should a vessel equipped with a buoy pack system become extremely low in the water due to leaks or an extremely heavy load, the flotation bags can be filled simply by triggering the gas generator system. The filled flotation tanks would provide additional buoyancy to raise the vessel to a more safe attitude or to provide additional freeboard for stability in heavy weather. In the shallow water test, divers were able to check the equipment prior to its activation.
Ready to fire!
With this accomplished,
Okay, here you go.
with the flotation tanks full, the boat takes on positive buoyancy of 500 pounds, a change of 1,000 pounds from its former state. Flotation bags used in this test were freely vented to the ambient sea pressure when full. This prevented the bags from bursting during the ascent of the vessel. The buoyancy of the flotation bags provides more than enough freeboard to make simple bailing possible. The equipment used in the tests is completely reusable, requiring only repackaging and reloading. Due to the inherent simplicity of the buoy pack, it was possible to run as many as 3 recovery tests in one afternoon. Shallow water testing proving a complete success, the test boat was taken to the deep water test site. It was determined by a conventional fathometer that the depth at this site was 720 feet. In this test, the flotation system was installed in the boat on the surface. Otherwise, the testing procedure was much the same as in the previous shallow water tests. After the rocket research boat was sunk, an underwater TV camera was also lowered. The camera was able to find the boat and determine its position. All systems being go, the charge was fired from the surface. And now the 10-minute wait for the boat to surface began. Owing to the greater depth and increased pressure, a somewhat larger fuel charge than was used at 30 feet was required to obtain 1,000 pounds of lift. Because of currents, the exact point at which the boat would come up was not known, but right on schedule, the rocket research boat was floating again, setting a world's record for intact vessel recovery. The deep water tests proved the fact that the system is well suited for underwater recovery. This system, combined with underwater eyes and arms, could be capable of finding and bringing to the surface wreckage or test objects from any of the ocean depths. Scientific data can also be gathered using a free-sinking buoyant recovery device operating independent of surface control. Adaptations of this gas generator system can provide underwater propulsion for torpedoes, submersible vehicles, and skin divers. Other designs could provide shaft power for underwater tools or other equipment. Ease of refueling such systems eliminates costly turnaround time, yielding a maximum system utilization. For marine salvage, underwater recovery, as a safety device, or as a source of underwater power, the rocket research designed and engineered system is a significant breakthrough in underwater technology. Whether it be the depths of the ocean or the limitless expanse of space, it is the goal of Rocket Research Corporation to continue to expand its realm of activity, contributing significantly to the scientific progress of our time.